The question here is which of the following phenomenon of light is involved in the formation of rainbow, and we have to write down the correct option. So I've taken the picture from the textbook over here. Now what you should remember, this is not a part of the question. The diagram will not be given. Just to explain the answer, I have taken it. So what you can see that this is the sunlight over here. This is the sunlight, and this being the sunlight, it is striking this. This is raindrops, right? It's a raindrop, as already mentioned. So at this point, refraction takes place. Let me write down these points. Say this I name as A, and this being B and C. So at point A, refraction takes place, and this is from A to B. You can see this is the place of dispersion. And at B, there is a total internal reflection takes place. And once again, it refract at point C, right? So you have to remember that these phenomenon has to be written in order. So therefore, one more time, that is a refraction, dispersion, total internal reflection, and refraction again. So let me see the correct. I can see this is refraction, refraction back to back. That's wrong. Refraction, dispersion, total internal reflection seems to be correct. And refraction, dispersion, and just internal reflection. It should be total internal reflection, right? Dispersion, scattering, and total. No. So this is B is the correct option in this case. Question here is where should an object be placed in front of a concave mirror of focal length 20 centimeters so as to obtain 2 times magnified real image? So where should the object be placed? That means we have to get U, right? U is the question mark. Object distance is what we have to find. And the mirror is what? A concave mirror. So, and whose focal length? So what we know for a concave mirror, F is what? Negative. So I'll write F as how much? It should be minus 20 centimeter. And we are given the magnification. Magnification M is ordinarily it should be 2, but now you see it's a real image. So in that case, we must place minus sign over here. Now check what in order to find U, I have listed the formula. You see, in order to get U, we need V and F. We have F, but we don't have V. So now I'm going to use this relation, that is M is equal to minus V by U. If I use this relation, we will obtain the relation between U and V. So let's figure out. I'm replacing M over here with minus 2 and minus V as it is. And U I'll replace. Where is U? U we have to get. So we'll write U as U only over here. Let me write it properly. This is V and this is U. Now check here. Don't place U as minus U. The sign is within U only, right? So do not place. So from here we got a relation between U and V, that is V is 2 times of U. Now we are going to obtain this for use this formula. So over here it's 1 over F, that is minus 1 over 20. So minus we write in the numerator is equal to, let U be U only, and I'll replace V with 2 times U. So it is 1 over 2U. Now check, if I take LCM on the right hand side, we are going to get what? 2 times U. This will be 2, and right, it should be 2, and this is 1. So now I can cancel this by 2 times, and that results to give you U as how much? By cross multiplication, right? This minus U is equal to, this is 3 into 10, that is 30. So that means U, that is object distance, is minus 30 centimeter. So this much is what we have to get, right? This much is what we have to get, and we got this as minus 30 centimeters. So we'll say that the statement should be the object should be placed at a distance of 30 centimeters from the concave mirror, right? We shouldn't end the answer over here. The end statement is this, that the object should be placed at a distance of 30 centimeter in front of the mirror. So you can see we are given a figure over here, and I read it, and it's given that it's an equilateral triangle over here. So that means each angle is how much? 60 degree. Well, what we can see over here, the ray AB is incident normally on the face. So as you know that whenever a ray is incident normally means that is along the normal, then it goes undeviated. So it will strike this over here, right? And if I write down the other angles that we know, this is 60, this is 60. This is normally, that means it is make an angle of 90 degree with a face. So this is 60, 90, sorry. So this will be how much? 30. And if I make another normal over here, this being 90, this whole is 90, right? So it's going to be 60. Right. So we'll say that A is the correct answer in this case. In this assertion reason based question, the assertion says what? That reflex action is automatic and rapid response to the stimulus. That's very true. Right? We know that it takes place, it's involuntary and it takes place automatically. And the reason says that these actions are controlled by brain. So what we should know that the first assertion is correct, but you should know that these actions are controlled by not by the brain, right? It's controlled by the spinal cord. Right? One more time. Reflex action is controlled by the spinal cord and not the brain. Therefore, we'll say that assertion is true, but reason is false. So assertion true, reason false is option C. The question here is to identify the nature of the mirror, mention the two characteristics of the image formed whose magnification is given. One more time, we know what the magnification of a mirror as +6, and we have to identify the mirror. Well, positive, let's understand M has two things. One is magnitude. How much is it? It is 6 times. So 6 times indicate that the image is larger. And if I look into the sign, it is positive. And positive stands for virtual and erect. That means together we can say the image is virtual, erect, and enlarged. And what you should remember, this is only possible in case of a concave mirror, because concave mirror, we are talking about mirror, right? Not the lens. So when the object is placed in front, by that I mean to say between F and what's that called? P, right? Pole. Yeah. And this is F. The image formed is virtual, erect, and enlarged. So this is what the refracted ray when produced backward, and the other say passing through the center of curvature, passing through the center of curvature. It will meet somewhere here, and the image formed is virtual, erect, and enlarged. So this is what? A concave mirror, and the characteristics, nature of the mirror, and mention two characteristics of the image formed. Yeah, that's virtual, erect, and enlarged are the characteristics. So in this question, it says that a hot plate of an electric oven connected to 220 volt line, it has two resistance coil A and B, each of 30 ohm, which may be used separately. Number one, it is should be used separately. Number two, in series, and number three, in parallel. What we have to find is the value of current required in each of these three cases. I remember one such similar question is there in your textbook. So we have three cases. Number one, when it is connected separately. Number two, when they are connected in series. And number three, when they are connected in parallel. So let's begin with the first case. In the case one, we have to use one of them, right, separately. Right. So the resistance is 30 ohm and the voltage supply is given 200. So V is 200 volt. So applying V is equal to IR, from here I can say I is what? V over R. That's right. Yeah, it should be V over R, and V is how much? 200, and R is 30. So we can reduce it, comes out to be how much? 6.67 ampere. That is the case one. Now case two, when these are connected in parallel. So we have, is it parallel? No, it's series. And we have to go in order. As you know, in series, the total resistance or equivalent resistance should be obtained by adding individually. That gives you 60 ohm. R is equal to R1 plus R2. Applying the same relation, I is equal to V over R. So I can say I is equal to V is how much? V is 200 only, and R is 60. So can be reduced further. This is by 3 and this is 10. It's coming 3.33 ampere. The last case, let's say if I do it here, the third case over here, This time these resistors are connected in parallel, right? So the total resistance or the equivalent resistance will be what? 1 over R is equal to 1 over R1 plus R2. Now calculating this, R1 is 30, R2 is 30. So that's 2 over 30. That is 1 over 15. Do not forget to reciprocate it as most of you do. So the resistance is 15 ohm, right? And we'll go by the same thing. We'll be calculating I, and that is I is equal to V over R, V which is 200, that divided by R which is 15, I can see. Can reduce by 5, 3 times, 5, 40 times. Right, and 40 divided by 3, that's how much? 1 time for 3, 10, 3 times 0.33 should be. This much is the case for the third case.